Thank you.
No problem. So just to introduce myself, David, as you said, yeah, I am a software engineering manager here at NYPL in the digital department. So I manage our team of backend engineers who work on a number of different projects, mostly dealing with sending metadata from here to there to support like a number of kind of access points, discovery tools for our research materials, for our circulating materials, for archival materials, and for other things as well. So we deal with a lot of metadata, which I'll talk about in a second, which is really great because it means that we kind of can manipulate this stuff. I was previously a technical team lead in our e-reading projects. So those are things like our Simply E product. You might be familiar with our in-house e-readings platform, Open eBooks, which is a similar platform for Title I schools. And then there's also, which was a project that I helped develop, Digital Research Books, which is a discovery layer for public domain and open access materials. And so that is kind of hoovering up a lot of data from Google Books, OCLC, other sources, and combining that into a single representation to kind of help facilitate access to those things. And that's kind of an experimental project that we've been working on for a couple of years, which is exciting and kind of how partially how I got into a lot of this kind of metadata and data pipeline stuff. Before that, I was working at Collective Access, which is a project some people here might be familiar with. It's an archival management CMS system. We also did a lot of kind of custom data pipelines. I think in that role, I think I worked on my biggest data pipeline, which kind of was dealing with 100 million plus paleontology records. That was one of the things that kind of, I'll talk about that in a second. And I have an MLIS from Pratt Institute. So I am trained as a librarian. I've kind of been working in libraries for a long time now. And I think this is probably true, maybe not true for everybody here, but I imagine true for some people here. I'm largely self-taught. I took one semester of Python in college, and then I've kind of learned on the job as I've been handed bigger and bigger projects and requirements. And I've done a lot of one-off data pipelines, and I've done enough of them to be tired of doing that. And so that is kind of why I'm looking at like what it has led me here and what's led me to the talk of like, it is definitely possible to write your own, data pipeline, to do your data ingest, to kind of customize anything. But the question is, do we want to? And what tools out there that make it easier? And so, yeah, that's me. That's how I got here. And please, I just want to say, like, if anybody has any questions, please either drop them in the chat or just raise your hand. I'm happy to stop and go back or explain things or just kind of clarify at any point. So yeah, so that's me. And then this is us. So NYPL Digital, our data. We have a lot of data sources. I'm sure everybody here is familiar with most, if not all of these. We have data coming in from our library management, from Sierra, our LMS. We have OCLC. For digital research books, we're dealing with stuff from HathiTrust, from Google Books, which is a very unique getting data out of Google Books. I don't know if anybody here has done it. It's kind of a fun, unique way that they have of doing that. And then we obviously have our controlled, authorities dealing with Google Analytics, other analytics vendors, and then just other vendors of things like ebooks, so Overdrive, Libby, stuff like that. We have a lot of different data sources, and right now our ecosystem is very diverse. A lot of our stuff is hosted on AWS, and we have different projects. So a lot of different projects have taken different approaches to doing this. Just sending data streams to Kinesis through queues and SQS or RabbitMQ. Just standard databases, cache layers like Redis, Elasticsearch, document databases, like all of these things, like all of this data is kind of going here and all over the place, and it's a lot to manage. We have things, we try to enforce standards like by using Avro schemas and all of this stuff, but it is very, very diverse, broad, used for a lot of purposes. And like this is a good thing because it means that we have the data that we need to serve kind of our diverse patron base. So researchers can have their level of access very fine-grained, advanced search, all that stuff, while more casual library patrons can have something that's easier. You can come in and search our digital collections, find an image, an old postcard of, a tax lot from Brooklyn from the 1890s or whatever it is that you might be just interested in, like a little more casual, a casual user. So this is all, which is great. And I think that we're really proud of what we've built. But it's a lot to manage. We kind of want to look at like what is going to be easier for us. And so that's kind of where Apache Airflow comes in. And I just want to preface this by saying, like, we're very early stages of using Apache Airflow. Like, this is like this slide is still where we're at for 95% of our work. And we have not put Apache Airflow into production yet. So we're just very much like looking at this, starting to roll it out. And so this is largely about like what what we're looking at using. And so Airflow, I don't know if anybody here has used it before or kind of looked at it. But it's a workflow management platform, like an orchestration tool for data pipelines. It's all native Python. It was started at Airbnb and would then kind of has become part of the kind of a core Apache thing. So it's very, very popular. It's been used by a lot of enterprise. It's used by a lot of large institutions. And it is built around this concept of a directed acyclic graph, which is DAGs, is what most people call them, which is a fancy term for essentially saying that you have data flowing through a set of tasks in a linear way. So it only goes one direction. And it does not flow backwards into a previous step. It just goes in one direction. You process data step by step. And they can run on a schedule. They can be triggered on a schedule. So roughly equivalent to a cron schedule, or specific events. Say you upload a file to a server or in a S3 bucket somewhere, and you want to kick off a processing job. Airflow can orchestrate that based on that event. And generally, it's an orchestration tool. The nice thing about being in Python is that it can you can write your kind of data parsing, transformation, your ETL pipeline directly in Airflow if you have like a pretty simple thing. So you can just write your Python there in the DAG module and then have that execute it. Or you can use it as a true orchestration service to have a kind of invoke an external thing. Let's say you, again, here run on AWS, so having it invoke a Lambda or some kind of serverless function or something else, or just trigger a job on a server that you control. And that would be something for more, something that's maybe going to be more expensive. You might want to do that. Let's see. Sorry, thank you. ETL, extract, transform, load, or ELT, sometimes extract, load, transform, depending on your paradigm that you want to use. We do ETL here. The nice thing, one of the nice things about Airflow is that it is distributed. There's a Docker Compose file that will spin it up locally on your machine. And there's also, it also is kind of like what Apache recommends is you run it as a Kubernetes cluster. I'll kind of get to this in a second. So that implies that you or somebody on your team knows how to start run a Kubernetes cluster, which is not true for us. I have tried to do Kubernetes in the past. It is very opaque and confusing to me. So kind of get into some of the ways to run it. That's actually one of there's advantages to Apache. There's ways to run it that are very, very easy. If you want to run a customized one, it gets complicated very quickly. There are many, many configuration options, which we are just beginning to scratch the surface of. So that's kind of the overview of what it is, and then the details in here. So on the right is just some basic pseudocode about how kind of what an individual DAG looks like, and you can see that it's pretty straightforward. You have you define the DAG itself, you create some tasks that run within that. You can see that there's something called XCOM in that pseudocode that is not extraterrestrial. That's not the video game. That is a cross communications. So that's a tool that Airflow uses to communicate between tasks. This is roughly equivalent to, it's essentially writing stuff to an internal database and then fetching it. And you can see you take those tasks, you wrap them in operators that are associated with the DAG. And then at the very bottom, which I hope people can see, that's a little close to the bottom of the screen, is that you just kind of tell the DAG, in what order to run those operations. And it's very straightforward, very kind of visual. And that's really nice because you can have that be very clear in your module itself. Fortunately, there is less random chance in writing DAGs than there is in XCOM. So it's not going to be like a 95% chance that the thing is going to work and then die. And it does have better error handling than XCOM as well. Sorry, I'm getting too deep in the weeds on XCOM references here. But anyway, it is like, this is very clear. And I think that this is just a very, very simple thing. You can see that it's just like schedule interval, just using a time delta of 5 minutes. Like, so like very easy to understand, very kind of like logical. And then you take that DAG and you load it into this Airflow thing. So it has a bunch of components. So there is a scheduler. I think that's pretty clear. The executor is what handles, that gets invoked when a schedule is run, and that delegates tasks to workers, which is why this is very recommended that you run this in some kind of containerized cluster environment, why Kubernetes is recommended, because then it can scale up those pods or whatever the Kubernetes thing is, and you can allow it to scale up the workers depending on how that works, because generally a worker will be a container that's running somewhere. And then you have your directory of DAGs. And then one of the great things about Airflow is it has a really, actually very, very nice, very full featured user interface that comes out, you get out of the box, and then you can use to do a lot of stuff. Obviously, it is not a GUI for doing task creation or DAG creation. Like that has to be done in code. But in terms of like invoking them, seeing the state, seeing if they've run, looking at logs, looking at configuring variables, so you have to rotate a key or something. All of that stuff can be done in the UI without requiring any kind of coding knowledge. So if you like I said at the beginning, if there is somebody on your team, like a product manager or just a supervisor who's like wants to see like, is everything running as intended? Like, is our data making its way into wherever this pipeline is pointing? Like they can see that. They can see that it's run successfully for the past 6 months. And then if it hasn't, they can see why. So that's really, really nice. So I'm going to show kind of like one of the simple at Airflow, our Airflow instance kind of is now. I could kind of walk through some of that. And then, so within each workflow, these are all like everything within tasks is you have operators, which is kind of like perform the logic. And then you have sensors, which can detect, let's say, like your file has changed, the database row updated, like those kinds of things. Or your table updated, added a row, updated a row. So yeah, that's pretty much it. So it's obviously much more complicated. You can get into a lot of the weeds about things like the scheduler. You can have multiple schedulers. There's like a celery schedule. There's underlying technologies that you can do to run a scheduler. So locally, you might have something that's essentially running single threaded. So it schedules a task, it runs the task, and it's all very contained and easy to spin up on your machine. And then in a production instance, you would have something that's very, very full featured that is running like multiple tasks, all of that. There's a lot of configurability. Again, so I don't want to jump ahead too much, but there's ways that like you can lessen that learning curve. So you can get it up and running, you can demo it. And then if you're like, okay, we want to put this into like big production for like everything, then there's ways to do that, but it would be more involved. And then, so that's what it is. And this is why we like it. It's all Python. So we're primarily a Python shop here. I have a bunch of Python engineers. Our IT department at NYPL is very busy, I would say. And because we have, 90 plus branches, they are maintaining machines across that whole thing. They are dealing with all kinds of stuff. So anything we can do to, kind of lessen the demands on asking them to spin up infrastructure for us is better. And this makes it very easy because we're just doing everything in code in Python. That is a big advantage for my team, and probably for other libraries as well. One thing is that we can configure a lot of things just by setting up the DAG. And I didn't really show this in, I did not show this in the kind of pseudocode I wrote there, but when you just create the DAG, you can configure, say, retry this many times, have a retry delay of 3, 5, 10 minutes. Email me if something fails, and all of these other settings. So instead of like worrying about like monitoring and setting thing up, like you can essentially just get this out of the box. So that's something that we really like. It allows us to give a lot more confidence in our data pipelines, as opposed to looking at something being like, my data's not here, and having to go back to the pipeline, figure out where it went wrong. Like we can kind of have that observability. It's very scalable. I'll talk about that a little bit more. The core concepts are pretty easy to grasp, I think, like essentially this idea of tasks, and like having that very easy kind of visual representation in code of how the tasks relate to each other is really, really nice. Or at least for me, maybe other people don't need that. I don't know, I do. The very, very friendly UI, which I'm going to show in a second. And actually, you can see at the bottom here, like the UI actually offers you a representation of each DAG as a graph. So you can see here that this is one that we have for persisting, for parsing the availability of ebooks from one of our vendors. This is just something we're experimenting with. This is the first one we're kind of running. You can see here that each green box, these boxes are green because this was a successful run. If one of these steps had errored, it would be red. And then we'd be able to click on it, view the logs, view the outcome, and see what went wrong. So this is really, really nice. And I'll kind of show more about this. You can see it's very, very easy. It's possible to have like branching paths. So, when you can see here that getting patrons is a much simpler process than getting polls and items and all of this stuff. So, and then we kind of bring that all together and persist that to our database as a final step. Operators like compare the separate DAGs with particular tasks. I'm sorry, I'm not.
Oh, sorry.
Generally, yeah.
Just looking at the code, I noticed the operators when you brought them up seem to have task 1 and task 2, and then you also told it, work on the demo tag. So is it kind of a thing where you might, different kind of tasks in different tags, or?
I think you could. I mean, that's not something that we've experimented with in terms of like creating like a reusable kind of utility task. But yeah, I think if you had a common operation, say, like, I think one thing that I can think of, and we haven't done this yet, but like something that we frequently have to do is obfuscate patron IDs or other kind of like PII. And that's a big part of some of our data pipelines. And like, that's a very common like we essentially have like our operation that we do for that. We pass it in, there's an algorithm that operates, it spits back out. Like you give it a string, it spits out an obfuscated string, like regardless of what string it passed in, it just applies that logic. So yeah, we could define a task or an operator that says do this and then import that. Which is not a bad idea. I think that would work. And oops, sorry. Where am I? Wait, did I skip this? Did I skip the slide here? I skipped the slide. I'm going to go back to the slide. So this is an important spot. So like that's one of the things that we really like is that like it has it really has, like, when you set this up, you have the ability to pull in a lot of dependencies, and those can just either be like local dependency. You can either just set this up as just import from a file, or one thing that we've done is actually build a local kind of utility package that we can import into these things, and like it can just import any packages as a dependency, which means that like there's very little limitations on what you can do, and that is really nice, which is a big advantage over certain things like we've run into some problems with this on AWS Lambda, where at least in the past, writing a Lambda that, say, persists things to a Postgres database, I think was at one point very, very annoying because it was missing some of the Postgres dependencies, and you need to explicitly create a layer for Lambda that would do it, and it was all of this work to make it work. Whereas like this is, I forget what flavor of Linux it's running on, but essentially just running on Linux, so you can just install any dependencies that you want. It also has a lot of integrations and plugins. So if you want to say integrate this into a Postgres thing, you can just, it has a connection for that. It has a connection for, I'm sorry, if there's anything that I'm talking about in terms of like AWS stuff or anything that could use more explanation, please stop me. I don't want to go through that. It even has integrations for stuff like we were experimenting with reading from a Google Sheet. We wanted to ask staff who are very familiar with Google Sheets, instead of asking them like learn a new UI or have them submit data directly to an API, so like update your Google Sheet and we'll read the data from there. and it had an integration for that. It was a little tricky to get it set up because integrating stuff with Google is difficult. Google's like process of generating an API key and process like that is very frustrating. But once we were able to figure that out, the actual integration does work really nicely. So stuff like that. And then another thing is that this project is still relatively new, and it's getting a lot better. So we are currently, I think the latest version is 2.7. We're on 2.4 for various reasons. But after 2.5, they've actually introduced a new, more streamlined way of writing DAGs. And I put this in a later slide. But it's essentially like makes it easier to kind of do communications, and it's more like writing a class than writing like it's more object oriented than the way that writing DAGs previously was very functional. You had kind of did each thing, stitch them all together, and you had a kind of functional. So there's now a way to kind of do it more object oriented, which is personal. I think it's personal preference. It's something that I'm more familiar with in terms of like a coding style. Any other questions about this slide or anything else I said? I want to go before I jump back real quick. Cool.
I have a question.
Sorry. Yes, please.
Okay, I understand. I think so. You've got whole buckets of metadata.
Yeah.
That come from different places.
Mm-hmm.
OCLC, your library catalog, ebook vendors, yay.
Yeah.
And you want to take this content and then dump it into more centralized things and do cool stuff with it and make reports.
Mm-hmm.
And you had lots of cool little tools ahead of time to do that.
Yeah.
Now, kind of, sort of, it might have gotten too big and you want an additional management tool to help you out.
Mm-hmm.
And you decided to kind of sort of buy in on this Airflow thing, which was developed by Airbnb and commercialized.
Yeah, I mean, it's commercialized. It's been open source. It's all open source. Yeah.
Okay. And all right, that's what I thought I needed to know. And what comes with a cool GUI that helps your non-technical types feel good and warm and fuzzy about this cool tool that you're using.
Yeah. And there's another advantage. So there's another advantage that we like, which is it means that we had to be doing this data parsing anyway. And so where we are now, actually, thank you for that's a good. So where we are before or now is we were orchestrating data processing jobs through a number of systems. Like we have data flowing through things, and so we're using things like we just have big long cron files for some projects. Other times we're using CloudWatch, which is its own flavor of cron. If anybody has used it, it has a special additional cron field that you can't just take your cron and give it to AWS. You have to add a new column because they wrote their own flavor of cron for some infuriating reason. And cron is just a simple way of is a syntax for scheduling things. Jenkins, which is probably cron underneath, and then Atlassian has a thing called Bamboo that we use, and it like runs things on premises for us. It's very annoying to use. It breaks. It's not nice. And we're using kind of all of these things. And why this was difficult for us is because they have very limited or no friendly interface. So when we're running processing jobs for cron, like unless someone goes in and checks out the logs, or like your cron mail, which is like, cron like kind of notoriously will send you mail if a cron job fails or succeeds, and that mail file, which just lives in your machine, can get really, really big. And like that can actually cause problems if you if you forget to check it for months or a year, and then it eats all your disk space. So there's like things that can go wrong. And ask me how I know that.
And this tool helps you manage that process a little bit more.
Exactly. So it's essentially, we don't have to. So I guess I'm getting into the weeds about this, which I apologize. The short version is that with Airflow, we can focus on writing our logic for parsing our data, producing those reports without having to create all of this infrastructure and manage all this infrastructure ourselves. We can essentially say, Airflow, run these things. We trust it. We know it'll work. we don't have to say maintain cron, maintain all of these systems, which we were spending a lot of time doing. So it actually means that like the people on my team and people at NYPL can spend more time applying their domain specific knowledge and doing boilerplate, like how do I run this processing job and make sure that like it is consistent. So it is really, really, really nice. That is like one of the big things that we want to get, that we're getting out of it. The other thing is that like having like using something like CloudWatch, where the orchestration logic in terms of what's triggering things and when what's getting invoked and when is very separate from our actual pipeline logic, which means that like you have to know where things are, and those systems are, you know, it's just a lot of knowledge that people have to maintain. So this is asking people to kind of understand a smaller system. Any other questions, Eric? Does that, any other follow-up questions? Does that help answer what you had?
Yeah, that's that. Yes, it did. Very good. Thank you very much.
No problem. Sorry. Okay, so let's take a look at let's actually have this open. So you can see here, this is kind of like our homepage. You can see here that we've written a few things against Access 360, against the Baker and Taylor ebook vendor, kind of like as a test, doing some stuff. So you can see here that this is like pretty easy. So we have runs, you see a success, failed, and all these things. And then we have a schedule, which says most of these are running every 5 minutes. This one that's been turned off was running hourly. This one runs every 3 hours. Then you just say like next run, last run, next run. And you can see some recent tasks. And I think if you can see over here, which everybody's kind of hiding from me, that's better. I can actually invoke it manually here. I can delete it. And then I can also look at the details for this. So I can look at the code right here. This is a more complicated one. It's almost 500 lines. You can see this graph. This is the last run. If I click on any one of these, I get a drop down. I can see what logs we output for this. And then I can just see there's a lot more kind of information here. So we don't really, we can see overall duration, we get some nice things. So in general, in terms of like, having observability, understanding what's going on with, not with the DAG in general, with all of our DAGs, but into each individual task about what's going on, where the time is. So some of the, we will be at a point at some point where some of these things need to be very performant, to keep things like patron records up to date with patron activity. So like we need to make sure that like that, we require, like make sure that this is updated within 3 to 5 minutes, stuff like that. So that this really helps with that. And then the other thing, you can see there's all these things, reschedules, triggers, all this stuff. We also have various things where we can control various variables, connections. A lot of these are default things. So we haven't configured all of this. We have to go in and update some of this. But you can just see here, there's a lot of things that it integrates with. SQLite, SOTP, Redshift, Salesforce, Postgres, Mongo, like essentially anything that you can think of, and some things that you probably don't if you would ever use. And yeah, it's really, so this is really, really, really useful. We can, and it's as simple as like, if I want to pause, if like, let's say I came into this and noticed that like all of a sudden, like all the recent tasks were failing, I could turn it off and prevent something from populating chunk data. Or not me, somebody else, the product manager could come in and say like, this is causing problems, and just pause it until we have a chance to investigate it. Which is a really good tool, I think, to have in our pocket. And you might notice that this has a very ugly URL, and this is because this is deployed from AWS has a kind of out-of-the-box solution, the way that they do for a lot of things, where they will just spin up an Airflow cluster for you. Of course, they charge a premium. Anytime they do this, they charge you a premium. So it's more expensive than running your own, but also, we're running a pretty small instance, so it is relatively reasonable for us. and a good thing to know. Any questions? Is there anything in here that people would want to look at in terms of kind of what we can see here?
When you say the pricing is reasonable, would you give a ballpark?
Off the top of my head, I want to say this is probably costing us a couple $100 a year. For running a small, like this is obviously running like relatively small, running relatively small jobs. I think it's less than $350 a month. I could pull it up. I could look right now to Amazon. So Airflow is open source. We pay nothing for Airflow itself. If you wanted to run Airflow on-prem on some machine, like you could run it, essentially for the cost of whatever that compute is. There are other services. So I'm going to talk about this. I can talk about this in a little bit. There are other services. The two big ones are, one's called Astronomer, the other one's called Dagster, that will essentially essentially have like the orchestration scheduler level running in their cloud, and essentially you kind of tell it like where your DAGs live, where you want the compute to happen, and they orchestrate everything from their little system, which we didn't like because it means that they control the scheduler. But those are tools that people like because it makes it a little bit easier, but it's essentially the same technology. I think that's even more expensive. I'm not actually sure. Azure, I saw Susan. Azure, I think all of the cloud providers have like either they have like a managed Airflow like AWS, or they kind of have their own flavor of this as well. So I know that GCP has, I forget what they call it. I put it in a future slide. And yeah, so I'm just going to open up the pricing because I think at the minimum, yeah, you get started for free, but like you can never get started for free on Amazon. Yeah, the price per hour, I think we're just running essentially the smallest thing, and then somebody could do out the math, but it's I forget exactly. I hope I'm not misleading anybody on price, but we priced it out and it wasn't crazy compared to what Amazon can charge you for some things. And then so there are a bunch of deployment modules. So Docker Compose is what we do locally. That's probably the easiest, fastest way to get it up and running. We actually have Airflow now integrated into our like local development for one project, and it spins up Airflow and it does a lot of stuff. It's pretty nice, just using a make file. So with a little bit of time that came together. AWS Managed Airflow is the simplest. It does come at a steep cost to compare to like what some other things are. And it hosts DAGs in S3, so you have to upload your DAGs in a very specific format. You have to be kind of aware of like how you're uploading things to S3. But once you get that set up, it works pretty well. The option for doing, if you wanted to have like your production environment mirroring your local development environment, like you could use Kubernetes. Again, please call me if you can figure out how to make that work, because I cannot get Kubernetes to work, even though I've been working at places that have used it for years now. I just don't understand it at all. They do have a Helm chart, I think that's what that's called. But it's essentially, you can use that Helm chart to spin up a Kubernetes cluster. So for someone who knows Kubernetes, that's a pretty viable option, I think. There's a lot of configuration options. Yeah, there's GCP Cloud Composer, which I don't know exactly what's relationship Airflow, but it's like Google Airflow kind of. And then there's Astronomer and Dagster, which are not Airflow, but are DAG based. So essentially they take the same, they take very, very similar. It's the same concept. It's just they run things in the cloud. So it's a little less, a little different. And there's probably other ones too. These are the ones that I'm familiar with. I did a quick Google. There was there's probably other hosted solutions, but these are things like for now, and when we're poking at it, we're using AWS Managed Airflow has been the easiest thing for us to do. Like we will probably, I would like to at some point move this to a Kubernetes cluster, both because we'll be able to run a bigger cluster for cheaper and not paying the Amazon premium there. But again, that means having to get some knowledge of Kubernetes. And so we have some open questions. Like I said, we're still in the early stages of kind of evaluating this or using this. And kind of like looking at this is like, how computationally expensive can these tasks become? We're doing, as you might have seen from that brief code sample that I kind of scrolled by, we're doing a lot of the logic within the task right now because it's pretty simple. It's fetching data from third-party APIs, doing some light transformation and loading it into a database or some other kind of data store. So that kind of logic works pretty well. It's pretty performant. But could we do something like author a PDF? We have a PDF authoring pipeline. Like that's probably too big. Could we run an ML model? Could we do other things? And at what point do we convert? Like those things are probably too big to do there. But like where between fetching data and authoring a full PDF file, like at what point do you just say, okay, this is now just orchestrating this process and not actually doing the logic itself? And then how do we roll this out to other units? So we're using this on a small set of projects. It's like, we don't want to invite everybody to just load their DAGs into one thing and then overburden our thing. But also we don't want to spin up a bunch of different Airflow instances because that could get quite expensive. And yeah, for anybody who follows the news, Eric Adams keeps on cutting our budget. So we don't want to just keep on expanding our costs. And then also how complex is too complex. So we showed one DAG that had a couple of branching paths. It probably had 6 to 8 tasks in there. Like how big should this get before it gets unwieldy? And people say you can write them really complicated ones. So we're not sure. These are things that we're trying to figure out. But overall, where we're going from here is we're rolling things out. We're looking at some hosting solutions. Like I said, we have a shared utility package that we're using to kind of importance of this. Like, this will hopefully going to use this as a kernel for more shared code to make it easier to import more functionality into this. And this is what I think about. Once we upgrade to 2.7 or post 2.5, the Taskflow API really makes writing DAGs very, very simple. We just have some decorators, class, you kind of throw it all together, you tell it what order to run it in. And this probably lowers the bar for other engineers and other developers here to kind of create these DAGs because it's like, it's very much writing like a class that you would invoke just in other code and requires less kind of Airflow specific knowledge. So that might be something that makes it easier for us to kind of onboard other engineers into this. So that's something that we really want to look at. And also we want to look at how we can do observability. Like right now, obviously the Airflow UI has a lot of information in there, but having to get someone to come into that and look at it, or make sure that we're sending the email, is a bit of a barrier. So how can we set up email alerts so people kind of get notifications? And we're also using New Relic. For anybody who's not familiar, is a kind of like a observability platform, something that looks at data, or I always forget it's like telemetry, just kind of performance of your applications. And that integrates well. That has an Airflow integration, I think. So we want to look at doing that. I will say, just as a quick aside, New Relic has a pretty good public service program. And we get a couple of seats, I think 3 seats or 5 seats from them for free. And it's a really, really good tool. It's something that we use a lot to kind of like make sure to watch our infrastructure. So I don't know what the process is for getting into their public service program, but it's something that's been a really big benefit to us here. So that might be something if people are looking at those kinds of tools. And they've been their team is very, very helpful. They do every year they do like a 2-week kind of pro bono thing where we get time with their engineers, or we got in this year where you can apply to get time with their engineers to help you set things up. So they're very time, and they actually get time with their engineers. It's really nice. So that's a plug for New Relic, for trying to get free New Relic for your institution. That might help because it's helped us. And yeah, so that's essentially it. So we are trying to do that. I hope that was interesting. I hope it was useful. And yeah, any questions or discussion anybody wants to have, I'm happy to do that. Wow, it's 11:45. I'm sorry, I did not mean to talk that long.
Hey, no, that's great. Thank you, Ed. I can say I personally learned quite a bit. Okay. Particularly, I saw one particular DAG was about, importing, physical book bibs, which is something I'm absolutely going to look at further. I guess I should. My question is, what are the next tasks that you can kind of see that you'd like to dive into? That would be like high benefit of building up a DAG.
So the big thing that we're working on right now is looking at how we can normalize our data from multiple sources, including our bid records and data from vendors into a single representation. So you might have noticed that there was one that said Ferber in there. So we're working on building out a database based on REMI and looking at how we can have that data flow into a single database and understand representations that way, which is, I'm sure everybody here appreciates, very, very tricky.
Very cool. Good luck with it.
Thank you. Jamil?
Learned a lot. Airflow had been on my radar for a while, so it's nice to see you start to implement. First quick question is, can you share your slides?
Yeah, I'm happy to share my slides. You won't be able to see the dashboard because it's obviously I'm signed in, but everything else, I'll post them in the Python4Lib slide.
Thank you. Oh, there was we weren't clear. If you could give a very non-committal ballpark of how much we're paying per year versus by month, because it almost sounded like was $350 a month, or was it a few hundred total a year?
So I don't want to. So I'm going to not answer that question right now because I don't want to mislead anybody about what we're like how much it's costing us, because I don't remember off the top of my head. And I want to go into AWS and look at exactly what we've spun up and what we're doing and what it's costing us, and then I can put that in Slack as well. And that's not a trade secret. It's not particular. I just want to say I don't think it's. Yeah, I don't know.
You think it's less than $2,000 a year, for example?
I think it is, but I don't want to. Again, I don't.
Yeah. Okay.
Yes.
No worries.
Yeah. Yeah. So. Yeah. Come
on. So in the summer we had Matt Lincoln from JSTOR talking about Pydantic as a tool, validation tool for metadata, and they're in similar situation where they have multiple sources, so that validation is an important job. Do you use any? Do you use Pydantic?
We do.
Okay.
That would actually be. I might, if people would be interested in what we. Again, it would be a good pros and cons, because we've actually been having some debate about how best to use Pydantic. And this because it's been proved very useful to validate our schemas when we're passing things back and forth, but also it's introduced a fair amount of overhead in terms of when do we stop validating things? Because like once you start do you validate every time you get a return out of a method? Because then it gets difficult to maintain. And then there's also, because Pydantic, I could talk about this for a while because it's an interesting thing. But in general, the answer is yes. Pydantic has been very, very useful for validating our scheme, for doing schema validation.
I think, Mike, that would be a really nice second presentation if you could get some real examples. And
what I could do for that is I could ask, if people would be interested, I could ask one of the engineers on my team to come and talk about the experience of using Pydantic. I think that they would be interested in doing that. Because there's been a couple of engineers who have been big proponents of doing it, and it's been really useful. But there's been some one thing I'll say is that figuring out how to make Pydantic play nicely with SQL Alchemy, because we use SQL Alchemy for our database models, has been tricky. They do work together, but anyway, Pydantic as a new project, there are some features that they haven't implemented yet.
Very cool. Yeah, just kind of looking at the time, I'll just do kind of one last call for any questions or comments. I see a few things in the chat. Looks like people learned a lot, and I know I did as well. So thank you so much, Michael. This was fantastic. Yeah, thanks so much for sharing.
Yeah, absolutely. It's my pleasure. I'm happy to come. Yeah, I will try to come by to some of these meetings, not just to participate, because I'm really curious what everybody's doing, and I'd like to be more involved.
Absolutely.
So
yeah, would love to have you. Yeah, and just kind of looking ahead at the calendar, I think the next one is scheduled for December 12th, and then that'll probably be the last one for the year, because the next 2 weeks would be the 26th. So I think we've called that one off.
Probably, yeah.
So yeah. The next meeting will probably be just more of an open discussion again. And I do have a couple of lines in the water I need to get out there in terms of more formal presentations. But as always, if anyone has any like presentation ideas or whatever, I can help coordinate that. Feel free to drop it in the Slack. So yeah, thank you so much, Michael, and thanks everyone for attending. It was probably one of the higher attended sessions we've had this year. Great.
Oh, I'm very happy to. Yeah, thank you everybody.
Well, thanks everyone. We'll wrap it up there, and I'll get the recording posted soon.
All right.
Bye.
I'm trying to stop sharing, but I can't figure out how.
Yeah.